Hello and welcome to my channel again. So today's video's topic will be the relativistic kinetic energy correction for the hydrogen atom problem. And on the previous video what we have seen is the relativistic correction of the spin orbit term that occurs due to the relativistic effect of the hydrogen atom. Now in today's video we will calculate the kinetic energy contribution. That means the electron is revolving around the nucleus, we will get the correction that much. So let's get started with this video. So I've erased the board and let me just start the video by writing the Hamiltonian that we have derived on the second video. That is the H kinetic energy relativistic effect is basically minus 1 by 8 m cube c squared p to the power 4. What we have to do here, we have to calculate the average energy like we did in the previous video. Now the point is, what will be the CSCO here? Because on the previous Hamiltonian, the spin orbit term, we had the spin and the orbital angular momentum both. So for that reason there was spin involved. But when we are talking only about the momentum P, then the Hamiltonian, the L square, total angular momentum, J, and obviously J squared, and Jz and Lz. Okay, these are the complete set of commuting operators. All of them will commute to the momentum. Now we have the good states or the states we need. So we can modify this p to the power 4. What you have to do, you have to calculate the n, l, m, j, mj, then p to the power 4 by, with a minus obviously, 8 m cube c squared, then n prime, l prime, m prime, j prime, mj prime. Okay, this is what we have to calculate. Let's say this thing is delta E relativistic kinetic energy. Okay, I hope this is okay. And we have to modify this p to the power 4 here. We know from the Schrodinger equation that p plus v minus h cut square by 2m grad is basically p square plus v psi equal to e psi. So p square equal to e minus v psi, if we want to say it like this. So p square is equivalent to e minus v. Here we have p to the power 4, so we will square on the both side and we will get p to the power 4 and e minus v whole square. So that's what we will do here with obviously a p square by 2m. I'm extremely sorry. That's p square by 2m. So we have to multiply 2m here obviously. Okay, and the 2m will get squared and we will end up with minus 4m squared. So minus 4m squared by 8 m cube c squared. What you have to calculate here is the average of e minus v whole square. Okay, e minus v whole square. So now this m will get cancelled, this will get cancelled, and we will end up with minus 1 by 2 mc squared with the average of let me just open the square, then e square plus v square minus 2ev, obviously in average. Now e is already an eigenvalue, so the average of eigenvalue is also a number. The average of a number is always a number, so I don't have to worry too much about this e square thing and will stay as it is. So e square plus the average will act on the potential v square minus 2e and the v. I hope till this part we are clear. Now before moving forward from here, let's say this is equation 1, so this is equation 2. Before moving forward, what we have to write, we know that V is minus Z squared by R. Okay, so if we take the square on both sides, V square equal to Z squared e to the power 4 by R squared. And what is the energy eigenvalue in the case of hydrogen atom is basically minus 1 by n squared Z square E square by 2a naught, where a naught is the Bohr radius. Okay, so we will use these three terms on the next step. So for that reason, please note these three terms carefully and write this so I can erase the complete board. Okay. Okay, so as you guys can see that I've written the term in entire expanded form, and so from here we can further do our approximations. We can do the squares and all, and finally we will end up with minus 1 by 2 mc squared, and then this is Z4 E4 by 4 a naught square n to the power 4 plus the average of 1 by r square is, I will write this first, Z square, then E4, then another Z square because of this 1 by r square, and then we will write L plus half and n cube a naught squared, then minus this whole thing. This whole thing is, if you see, Z cube, there is a minus, this minus and this minus will get absorbed, and there was a minus because that was E minus V, so this minus will remain still and these two minus will get cancelled out, and this will give me a Z cube and a e to the power 4. So Z cube e to the power 4. I'm not multiplying everything all at once because I know that all of these figures can get a little bit of messy. So it's very important that you pay attention to each and every term and from where the minuses are getting cancelled and all. And on the previous class we have already told that what were the values of alpha, and our final goal from this entire expression will be to reduce the entire term into form of alpha and n, as we have done in the previous video, that the term will go Z to the power 4 alpha to the power 4 by some n to the power 4, or we can have terms like this, say a plus b, and this will be an n cube term and it will have an extra n. This term will behave like this. Okay, so yeah, so Z cube e to the power 4 and then n square a naught, n square a naught, and we will end up with Z by n square a0. This is due to the 1 by r. Okay, from here we can write Z to the power 4 e to the power 4 will be common out, and by 2 mc square will remain as it is, and it will give us 1 by 4 a naught square n to the power 4 minus 1 by n to the power 4 a naught square n to the power 4 a naught squared plus 1 by a naught square n cube L into a naught square cube Z to the power half. Okay, fine. So this is L plus half. Okay, So you can see that this is 1/4 minus 1. This will give me a minus of 3 by 4 n to the power 4. I can take this n to the power 3 common out, obviously, and this a naught squared also. I will end up with z to the power 4 to the power 4 2mc squared with a naught squared n cube. Okay, n cubed, and then 1 by l plus half, then minus of 3 by 4n. Okay, so as you can see from here already that this has a into the power 4 dependence, and now if you do the workout from this whole term, you will finally end up with a handsome figure, that is z alpha to the 4 mc squared. Even the mc squared will stay on the same place, 2n cube 1 by l plus half minus 3 by 4n. This is delta E relativistic kinetic energy. So this is our final expression, and the takeaways will be same from the previous video, that it depends on alpha 4 and n to the power 4. Not directly n4, but there is a term that is n to the power 4. Most importantly, alpha to the power 4. So I hope that you have understood the video, and if you have doubts, obviously you can comment down below. Please keep practicing these things, otherwise you will forget. So thanks for watching.